Alright, Morty, imagine you're trying to find your way out of a massive maze. That's basically what a neural network is doing with data.
But Rick, isn't the maze just like data all jumbled up?
Yeah, Morty, and the neural network is this tiny, clueless rat trying to find cheese in that maze. It starts by making wild guesses. That's your random initialization.
So, the rat is just running around like an idiot at first?
Pretty much, Morty. But then it starts learning. It takes tiny steps in the direction that'll get it closer to the cheese. That's your gradient descent.
Like, it's going downhill?
Exactly, Morty. It keeps taking these tiny steps in the direction of steepest descent until it finally finds that cheese, minimizes the loss function.
But Rick, what if there's like a bunch of paths leading to the cheese? Won't it get stuck in a loop?
Morty, that's where momentum comes in. The rat doesn't just follow the steepest path, it builds up speed and keeps going in the same direction, even if there are small hills along the way.
Okay, so like it's running downhill and carrying that momentum like when you're skating and you just keep going?
Right, Morty? And there are other tricks too, like adaptive learning rates. Imagine the rat starts off running fast but slows down when it gets close to the cheese.
Wow, so like it learns how to learn better? That's crazy, Rick.
Yeah, Morty. And get this, there are even zeroth order optimization methods where the rat doesn't need to know which way is down, it just feels its way around using random vibrations.
But Rick, how does the rat know when it's found the cheese? What if there are multiple cheeses?
Well, Morty, that's where batch normalization and skip connections come in. They help the rat explore different paths and avoid getting stuck in local minima, those tiny valleys that seem like they're the bottom but aren't really.
So, it's like the rat is using its friends to help find the best cheese?
Yeah, Morty, and these techniques are why neural networks can do everything from driving cars to curing diseases. But they're not perfect. We still need explainable AI to understand how they make decisions.
Wow, Rick, this is all so fascinating.
Yeah, Morty. And who knows? Maybe one day we'll have quantum neural networks that can solve problems even I can't understand.
Quantum like quantum physics? That's nuts, Rick.
Yep, Morty. And it's all powered by the humble gradient descent. So if you ever forget how a neural network learns, just imagine that tiny rat in a maze.
Okay, Rick, but what about the other stuff you mentioned, like the black box problem and explainable AI?
Well, Morty, that's a whole nother can of worms. But for now, just remember, understanding gradient descent is key to unlocking the power of neural networks.
I think I get it, Rick. Thanks for explaining.
No problem, Morty. And hey, if you want more educational videos like this, make sure to follow us. We've got plenty of crazy science to share.